Bismillahirrahmanirrahim. In this video, I'll be explaining how to calculate the MR, which is the molecular mass, and I'll be explaining the first use of the molecular mass that you'll take in your syllabus, okay? How do I find the molecular mass? It doesn't matter whether I have an element or a compound. The molecular mass is the total mass number of the atoms present in a molecule, okay? So for example, if I told, you have elements that are monoatomic and diatomic. So if I ask you, for example, to find the mass number of a helium molecule, okay, I just told you find the MR. Oh my goodness, this is really thick. If I told you to find MR of helium molecule, it's not going to be the same as the MR of an oxygen molecule. Why? Because helium is monoatomic, which means one molecule of helium literally has one atom of helium. So I'll take the mass number of helium, the mass number one time, okay? But if they mentioned a diatomic element, which is an element that has two atoms per molecule of this element, I'll take my mass number that is present for this element and multiply by 2. Helium, okay? The mass number for helium is 4. How did you know that it's 4? The mass number is always the bigger number. Like you see two numbers related to each element, just know that the bigger one is the mass number. It can also be called the nuclear number because this mass itself is contributed by the nucleus. But anyway, I know that because helium's bigger number is 4, that the mass number of helium is 4. So the MR of one helium molecule is going to be 4. Okay? For oxygen, I know that oxygen is diatomic. How do you know? All of group 7, which are these, the halogens, and oxygen and nitrogen, are diatomic elements, which means they exist as diatomic elements. Like if I find oxygen in the air, it's not going to be just one oxygen atom that is not bonded to any other atom moving around. No. You find oxygen molecule, just know that immediately it's two oxygen atoms bonded to each other. Any of those in the red boxes are diatomic elements, so you can memorize them, you can keep looking back on this, but just know that it's entirely, like all of group 7 and oxygen and nitrogen. These are diatomic elements, okay? So 2 atoms per molecule. If I know that there are 2 atoms per molecule of an oxygen molecule, and one oxygen molecule has a mass number of 16, because 16 is a bigger number, I'll say, okay, 16 multiply 2, which is going to give me 32, and this is going to be an MR of this oxygen molecule, okay? If they told you to get the mass number of an oxygen atom, is going to be 16, but because it's mentioned that it's a molecule, and a molecule of oxygen has 2 atoms, because oxygen is a diatomic element, you'll multiply with 2. I'll be using the other examples that I drew here, so we can keep answering. First of all, we calculate the MR of elements, and then we'll move on to compounds. So for example, I have neon, and I'll go look at my periodic table. Is neon a monoatomic or diatomic element? Wallahi, neon is a monoatomic element. So what does that mean? It means that there's only one atom per molecule of neon. So I'll say, okay, the MR of neon is going to be 20, which is the bigger number, and only multiply 1, which is also going to be 20. It's not going to change, okay? But that's the MR of neon. Bromine. I'm going to go look in the periodic table and see where bromine is. I see that bromine is present in group 7, which means that bromine is diatomic. So I need to fix first of all, before I start a calculation, you can never write elements that are diatomic as without the little 2 right here, because then that just means that you're calling them monoatomic. But here, I corrected my mistake. The MR of bromine, which is a bromine molecule, has 2 multiplied the mass number of one bromine atom. Okay, one bromine atom, let's look at the bigger number, and it's 80. So you're going to say 2 multiply 80. So you say 2 multiply 80, and that's going to be 160, I think. But that's the MR, okay? That's for elements. If I move on to compounds, you'll see that in elements, I had the same type of element. I have the same type of element, okay? The same type of atom, okay? Here, there were 2 atoms in the molecule of bromine, but both atoms were bromine atoms, right? When you go to compounds, you'll see that in compounds, there are different types of atoms. Not the same type of atom twice or 3 times. No, different types of atoms. So here, what do I see? Wallahi, I see that there's 1 carbon atom and 2 oxygen atoms. How do you know that? If you have an element, the number that's present right here is related to how many atoms of this element that you have. So if I have no number, it means that I have 1, and any other number means the other number. In this example, you see that in carbon dioxide, you have CO2, okay? The C doesn't have any number, I am assuming that there's only 1 carbon atom, okay? The oxygen has a 2 to its right, which means I have 2 oxygen atoms, okay? So that's not a 20, this is a 2 oxygen, okay? But if I want to find the MR of this compound, I'll need to find the total mass of the total mass number of the total number of atoms in this compound. So I have one carbon atom and two oxygen atoms. I'll say 1 multiply the mass number of one carbon atom plus 2 multiply the mass number of a single oxygen atom. So you go to carbon. Carbon, the bigger number for carbon is 12, which is the mass number. So you say 12. 1 multiply 12 plus. We said for oxygen, the mass number is 16. So you just say 2 times 16, and whatever you get is the answer. Okay, I added in a calculator, and 44 is the MR of carbon dioxide. The next example, you use the same logic, okay? If the number is to the right of a certain element, it corresponds to this element, and this element only doesn't go to the other elements, طيب? Unless there's a certain, example that I'll be using. But anyway, I see that I have two silver atoms. How do you know it's silver? Just know for now that Ag is silver. But anyway, I have two atoms of this Ag thing, صح? So I say 2 times whatever the mass number of one Ag is, plus I have Cr. Okay, how do you know the difference between them? How do you know which one's each element? This is one element, and this is one element, and this is one element. How do I know? Wallahi, in elements, the first letter, if the element itself is the symbol is more than one letter, just know that for this element, the first letter is going to be capital, and whatever other letters you get for the rest of the element are going to be small. To know where an element starts and stops, look at the capitals. طيب أنا لو عندي capital letter هنا وبعده small وبعده capital تاني، أعرف إنه capital ده it is the beginning of an element, and whatever is here, this is the one element. طيب if I have I have two Ag atoms, and I have one Cr atom. Okay, so 1 multiply whatever the mass number of Cr is, and I have 4 oxygen atoms, so I'm going to say 4 multiply whatever the mass number of one oxygen atom is. And you'll see all these symbols in the periodic table, so you don't have to memorize the mass number for any element. It's fine, okay? Yeah, that's it. And because there is no number next to Cr to the right, you know that it's one atom of Cr, chromium, okay? طيب, this is the next example. You have Na2SO4. How do I do this calculation? I look at the capital letters. How many elements do I have here? Wallahi, a capital letter starts here, and there's a capital letter here, which means this is one element. طيب. And then here's a capital letter, and right after it is a capital letter. فمعناتها this one letter is an element. And then this is oxygen. طيب. I say, wallahi, I have 2 multiply the mass of whatever one Na atom is, plus 1 multiply the mass of one S atom, plus 4 multiply the mass of one oxygen atom, okay? And whatever number you get, you calculate in the calculator, and you see if your answer is correct. I'll be sending these with the actual answers, so you can compare whether you actually got it correctly or not. But this is the example I've been waiting for. What do you do when you have a bracket? What does a bracket mean? Okay, let me start with the simpler part of the compound. I see this entire compound right here. طيب. I have Ca, and then brackets, and then there are elements or letters in between the brackets. صح? Let me look at the first thing that's outside the bracket, which is the Ca. There is no number to the right of the Ca, which means I have one Ca, which is one calcium atom, okay? Plus, what exactly is going on? When you have a certain thing in a bracket, or certain elements in a bracket, and there's a number outside the bracket and a number inside the bracket, just know that this number outside the bracket, you multiply it with the number of atoms for each atom present inside the bracket. So for example, ignoring the 2, I'm going to ignore this 2 that's outside for now. This 2 that's outside for now. I'm going to ignore it and act like it's not there, and see how many atoms I have without the 2 being there. So if I look at this n right here, there is no number next to the n, which means that I have 1 n atom, plus I have 3 oxygen atoms. Like, what does this 2 do? It multiplies the number of atoms that you have inside the brackets by 2. So you take this whole thing and you multiply it by 2. What would that give me? That would give me 2 nitrogen atoms plus 6 oxygen atoms. And then you do whatever calculation we did above. And you say 1 multiply the mass number of calcium, which if you look at the periodic table, I think it's 40, plus 2 multiply whatever number is the mass number for N, which is nitrogen, plus 6 multiply whatever the mass number is for oxygen, which you'll find in the periodic table برضو. And then whatever answer you get, That should be the answer if you did this calculation. So what do I keep in mind? I keep in mind that this number that is outside the bracket, you multiply it with the number of atoms. Each atom that's inside the bracket, you multiply it with this number that's outside. So if I have 2 nitrogen atoms inside the bracket and there's a 3 outside the bracket, you multiply this 3 with the 2 nitrogen atoms and you get 6 nitrogen atoms. Okay, so that's it. This calculation of MR that I used in the previous examples, which are right here, I'm going to use it to solve this question. Like, before you solve this question, you need to know that gases move through the air by diffusion. Okay, so I have 2 compounds right here. I have HCl and I have NH3. Okay, when HCl and NH3 react together, they give you a certain compound, and this compound has white smoke in the air. Like, if you see white smoke in a certain area, just know that the product of NH3 and HCl has formed. What is the product? It's NH4Cl. You can try to calculate the MR for this as extra practice, but that's not what we're gonna need for this question. If I know that the reaction between HCl and NH3 is gonna give me NH4, and NH4 has a certain appearance. Yani if I see it in a certain place, I know that NH4 has formed there, which means that HCl and NH3 reacted in that place. They met each other there. What does that give me? That gives me a hint to know the diffusion rates, or you can use the diffusion rates to guess where this compound will form. I know that NH4Cl, when it forms, is going to give you white smoke. So at any point, if I see white smoke through this tube, okay, just know that this product has formed. Okay, in this tube, this HCl is going to move like this, and this NH3 is going to move like this. Wherever they meet, they'll react and form NH4Cl, which will form white smoke, and you'll know that NH4 is in that area, which means that they met in this certain point. Okay, so to find the meeting point, just know that that's where the NH4, the meeting point is where you find that white smoke. Okay, how do I know where the meeting point is going to be? Wallahi, I said that HCl is going to diffuse to this side, and NH3 is going to diffuse to this side. Are they going to diffuse at the same rate, with the same speed? No, because diffusion relies on 2 factors that you'll be taking. The first factor is temperature, but if we assume that the temperature here is constant and that it didn't change, the other factor that would make HCl diffuse at a different rate or a different speed than NH3, this factor would be the MR, which we kept calculating above. So what do you need to do? Just keep in mind that the lower the MR, the faster the molecule. Okay, lower MR means this molecule is lighter and it travels faster. If the molecule itself is heavy, like it has a higher MR, it's going to take a long time to get to wherever it needs to get. So you calculate the MR of HCl, MR of HCl, and the MR of NH3. Okay, I see that there's 1 H atom and 1 Cl atom, and here I see 1 nitrogen atom and 3 hydrogen atoms. So you just find the mass for each element present, and you multiply with the number of atoms present for the element, and you add this all up to get the MR. So for example, I have 1 nitrogen atom. 1 nitrogen atom has a mass of 14, so I say 14 plus 3 hydrogen atoms, and the mass for 1 hydrogen atom is 1, so I'll just say 3 multiply 1, and that would give me 14 plus 13, that is 14 plus 3, it's 17. That's the MR for ammonia. For HCl, the mass for 1 hydrogen atom is 1, and I already have 1 hydrogen atom, so I have 1 plus 1 chlorine atom. 1 chlorine atom is 35.5, that's the mass for it. You can see in the periodic table, chlorine, 35.5. You go back here, and you say plus 35.5, and that would give you HCl MR of 36.5, whereas the NH3 is 17. Which one has a higher MR? Clearly the HCl, صح? Which means that the HCl is heavier and it's gonna travel at a slower rate. It's gonna be going كده بالراحة, while the ammonia is gonna be going really quickly. So where exactly are they gonna meet? They're gonna meet closer to the slower compound, the heavier MR. They're gonna meet closer to the HCl. What does that mean? That means that if this B is the middle point, they can't meet in C and D, because that would mean that the HCl travels faster than the NH3 and they met closer to the NH3. But since we said that the NH3 travels faster, like diffuses faster than HCl because it has a lower MR, it's not going to be closer to the NH3, obviously. It's not going to be in the middle point. To show that NH3 أصلا is faster than HCl, that means that it has to be closer to the HCl. And the letter here that represents the white smoke forming closer to the HCl is letter A. So if you were asked where would the white smoke form, or where would this product form, you would tell them answer A. Why? Because NH3 diffuses faster than HCl, as NH3 has a lower MR. So NH3 would be going, and MR and HCl would still be going بالراحة كده, and they would meet right here. So that's, and you would see the white smoke, and then how you know that NH4 has formed, NH4Cl.